Now this is the Latin square design, and it's n set of numbers from 1 to n arranged in a way that no row or column contains the same number twice, and it's used when the researcher is going to control the variation in an experiment in terms of rows and columns. And its advantages are that it's suitable when there are two external sources of variation, and it's also easy to analyze. Its disadvantages are that its number of rows, columns, and treatments has to be the same. Squares must be at least as large as 5 times 5, meaning 5 rows, 5 columns. So the number of degrees of freedom degrees of freedom for error is large enough, and the effect of treatment must be about the same across rows and columns. Now I'm going to show how it looks like. As you can see, there are rows and columns, and no letter or value is repeated the same in either row or column. And the row sum is where you add up the rows. Column sum is where you add up the columns. Treatment is where you add up them diagonally from top left to bottom right. And this is a total sum of squares where you just add them all together. And the Latin square design ANOVA table. So you have the sum of squares, degree of freedom, mean square, and F value, rows, columns, treatments, and error totals on the bottom. And so you can find the mean squares for row and column from the sum of squares, but for mean squares of treatment and error, you can use these formulas specifically. Sum of squares treatment over k minus 1, sum of squares error over n minus k, and for the F value, it's sum of squares treatment over sum of squares error. And when you find your F value and it is larger than the F statistics, you reject the null hypothesis. And if it is not, then you fail to reject the null hypothesis. And this is an engineering example where you could compare two pipes and how strong they can hold a constant flow of water. And again, if whatever your null hypothesis is, you find the F value and reject or fail to reject in terms of which one is stronger and can hold that constant flow of water. And that is the Latin ANOVA table and Latin square design. Thank you.